Hello, everyone, and welcome to this week's podcast or talk. I'm going to be talking through the long COVID microbiome, which I am going to be putting out there in the public domain because I think there is some meat to the bones with regards to looking at the microbiome with regards to improving long COVID outcomes. My name is Rachel Jesse. I am a nutritional therapist and naturopath, and I've been specifically researching long COVID, natural interventions for long COVID, but also doing a deep dive research into the long COVID microbiome through looking at the studies that are being published, through collaborating with other doctors who are looking in this space, but also collecting now lots of data on the tests that I have been running in clinical practice. So I'm going to talk you through what the microbiome is and what it actually does. And then I'm going to present what I believe to be the start of discovering what the microbiome phenotype looks like. And then I'm going to talk through some of the things that can affect the microbiome, such as medications. We'll talk a little bit about SIBO as well, and then some of the options that you can use for testing and some basic interventions to get you started with regards to looking at the gut microbiome, because there is this preconceived idea that we need to be chucking loads of probiotics at a disrupted microbiome, and that may not be the case. That's not what the research is actually telling us at the moment. So what actually is a microbiome? So there are two terms that are used in the research. One is microbiome, which the correct term for that is a collection of bacteria, viruses, yeasts, and parasites and other microbes that live in a community together. Whereas the microbiota, which is another term that you'll come across, is the actual correct term used for the microbial communities that are in the host or on the host. So for the purposes of this talk, I'm going to refer to the human microbiome as the microbiota. So there has been a lot of research into the gut microbiota, and that research has exploded over the last 10 years. And we are seeing companies such as Danone and Nestle investing lots and lots of money into microbiome research to develop products, to enhance their products, and also there are other kind of biotech microbiome companies that are looking at gene editing of microbiome or gene editing of certain bacterial species that live within the microbiome. And that's kind of opening up a world of things for cancer therapy or treatments for cancer therapy and treatments for Alzheimer's disease. So it's a very, very much an evolving area of research, and it's something that we can't really ignore now, and we can't ignore it in clinical practice. So when I talk to my clients about what a microbiome is, I use an analogy of the vegetable patch. So you would have good quality soil, and that soil would represent the lining of our gut and the mucus secretions that it produces to protect itself. And then you would have the seeds that germinate and grow within that soil. So that's kind of my analogy for the probiotics or the beneficial bacterial species that we need to promote our health and our longevity. And then you need to feed those seeds with the right composite or the right components in order to allow them to grow and proliferate and flourish. And that's my analogy for prebiotics. And so if you have all of these components in place, the seeds are going to turn into plants and provide additional nutrients and other beneficial properties over and above the probiotics and the prebiotics. So we refer to those, that's my analogy for postbiotics. So when you're breaking things down, you've got the terrain, you've got the environment that the microbiome grows on, you've got good bacteria, so those are sometimes referred to as probiotics. Then you have the prebiotics, which is the food for the probiotics or the beneficial species to grow. And then you have the metabolites that are generated from those microbial species, and we'll talk about those in a moment. What the microbiome does, so the research is telling us now, we've got some good evidence to suggest that it modulates the immune system, it supports gut motility, It improves nutritional status. So there's certain vitamins that can be produced by gut bacteria. So the B vitamins and biotin and vitamin K can be produced within the gut microbiome, and it may help to improve the absorption of nutrients such as calcium and iron and magnesium and potentially zinc. It helps to regulate gastrointestinal integrity, so it supports the health of the gut lining. It protects against pathogenic microbe colonization. So if any pathogenic bacteria either come in through the host or begin to grow and proliferate from the natural colonization within our gut, those beneficial species will, if they're in the right amounts, will keep those at bay and keep those from causing any kind of major problems. It can support kidney health, and it supports xenobiotic metabolism. So a xenobiotic is a chemical substance within an organism, so within us, that wouldn't naturally be produced. So it has to be introduced by the body, and then there's certain detoxification pathways that xenobiotic will go through. So xenobiotics can be beneficial or detrimental. So polyphenols, for instance, are classed as xenobiotics, as are pharmaceuticals and pesticides and herbicides and mycotoxins. So the gut microbiome will help to deal with all of those. And then the microbiome produces short chain fatty acids and other metabolites. So those would potentially interact with the cardiovascular system, the mitochondria, the liver, the lung, the kidney, and also the brain. And there is a huge area of research on the gut microbiome and the brain. And I just wanted to show you and highlight that there is a lot going on with regards to the research on the gut-brain axis. And this is where certain metabolites that are produced from the gut can actually cross the kind of gut lining and either access the brain via the vagus nerve or systemic circulation. But you can see here, this slide is just a picture from a really excellent review that was released in 2023, where the researchers, they examined data from the CAS content collection. So this is a really large database of published scientific research and information. And what they did was they collected all of the information on the gut microbiome and its interaction with the nervous system, and publish this research to give a really good overview of how the metabolites are involved in our neurological function. So you can see from this particular screenshot here, or this screen grab that I've got here, you've got on the left-hand side here all of the gut microbiome metabolites that are produced, and you might recognize some of these. So serotonin, cholesterol's in there. You've also got lactate and butyric acid. So all of these components are actually produced by some kind of interaction with the gut microbiome. And this kind of infograph shows you how all of these gut microbiome metabolites go on to support neurological function. So you've got involvement with neurotransmission, you've got blood-brain barrier integrity management, you've got brain neuron and energy metabolism, you've got neurodevelopment, neuroprotection, and then bile acid synthesis. So it really does highlight how important the gut microbiome can play in the role of neurodegenerative diseases. So when it comes to long COVID, there appears to be a specific phenotype coming through, and the reason for that phenotype may be related to viral persistence. So there is now a growing body of evidence to show that viral persistence is occurring within the gut, and that really relates in clinical practice because a lot of people are experiencing GI symptoms as a result of COVID-19 infection, potentially vaccination as well. And then Carlo Brogna, as you may know, if you've been following me, I really heavily promote Carlo Brogna's research because he actually found in vitro that the SARS-CoV-2 virus can infect the bacteria within the gut microbiome. So that's known as a bacteriophage. So just alone with these two mechanisms, there is a potential consequence of that affecting the microbiome on a very significant level. So that would mean that it could potentially affect the gut-brain axis, so all of those metabolites that I showed you in that last slide, the gut immune axis, and also the gut mitochondria axis as well. So there is plenty of research out there to show that certain microbes and certain pathogenic microbes, if they're allowed to grow and proliferate in the gut microbiome, can become problematic and affect all of those areas. So we'll move on to my next slide, which is a collection of the published research, a collection of my clinical findings, and a collection of case studies from other researchers who are looking at this. And it's helped me to form a phenotype, or the startings of a phenotype of the gut microbiome in long COVID. So you can see a decline in bifidobacteria and also the lactobacillus species. You'll see a decline in Akkermansia muciniphila. There's a little bit of a caveat there because we've had a cohort of patients who've actually had really high levels of Akkermansia, and that may be related to different immune reactions that are going on in the body. So Akkermansia has been correlated with conditions such as multiple sclerosis. So it's more of an autoimmune type presentation where this appears to be raised. However, in a majority of long COVID patients, Akkermansia has been either wiped out or it's really, really low. So these bacteria just alone are really responsible for helping with gut membrane integrity, supporting the immune system, supporting the gut-brain axis. And so when you have a decline in these, there's then this increased risk of growth of more pathogenic style bacteria, which naturally live within the gut microbiome, but if they start to grow in numbers, they can cause problems. And also it leaves a gap wide open for the growth and proliferation of fungal species, so species from the Candida and the Aspergillus range. And then going back to these kind of not so friendly bacteria, if they're allowed to grow and proliferate, these particular bacteria are known as gram-negative bacteria. And that simply means that they carry a lipopolysaccharide on their surface, on their membrane. And this lipopolysaccharide is known as an endotoxin, and it can be absorbed through the gastrointestinal tract into systemic circulation. And this can activate a number of inflammatory processes through the toll-like receptor pathways. So when you have this immune activation going on and it's persistent from this viral persistence, then you're going to see a lot of the consequences of long COVID. So this could potentially look like microfibrin formation, amyloid plaque formation, and also there are roots then between the gut and the brain, because it seems to be that the SARS-CoV-2 virus or the spike protein is able to infect the vagus nerve, so that provides a direct route up to the brain. So there's a lot going on here, and I'm going to do a separate podcast to really break this all down and get a little bit more into the science. But we're generally seeing this takedown of keystone bacterial species, an increase in either fungal or lipopolysaccharide producing bacteria. And then as a result of that, you're seeing a decrease in butyrate, which is it's a short chain fatty acid that helps to protect the barrier, but it's also been implicated in many of the axes that we see within the gut microbiome and the immune system, the brain and the cardiovascular system, and much more. So that's a really high level overview. There's a lot more science in here, and one of the concerns is that as our microbiome starts to evolve as a result of this evolutionary pressure of the spike protein, we might start to see bacterial species or microbial species that we've never seen before in the gut microbiome. So we need to be quite fluid with our research. We need to be quite adaptive in clinical practice, because we don't know whether that's going to be beneficial or whether that's going to be detrimental. I would say that at the moment, the clients that I'm working with, this type of phenotype is pretty detrimental. And when you start to put in place interventions to bring up some of these keystone species, then things start to improve slightly. It's not the cure-all, but it can be a really good strategy to use alongside other interventions. Also, other researchers are proposing that once a particular species has been completely wiped out, so if you're consistently not getting any detection of bifidobacteria, for instance, then it's unlikely that it's ever going to return. And probiotics and fermented foods are not going to replace that species, because, to be honest with you, those are not, they don't colonize within the gut. They may exert some beneficial properties once they're going through the gastrointestinal tract, but they won't colonize and they won't bring up that growth of the bifidobacteria. So it's not, we know that it is not working, that if someone's got low bifidobacterial levels, you put bifidobacteria in through supplements and it's not increasing it at all. Fecal microbiome transplant may be a good route to get bifidobacteria back into the gut, but there are problems with that, because we don't know whether a fecal microbiome transplant actually colonizes in the gut, but certainly some people are receiving benefit from that. At the moment, all we can really go on is introducing foods into the diet that can promote the growth of these species. Now, I must say I've not seen a complete zero takedown of bifidobacterial species. If this is kind of allowed to happen and continue, it can have quite negative consequences on the population. But I'm just not seeing that. You see a tiny little amount, you can see a tiny little amount in stool test. And as long as you have that, you have the opportunity to be able to feed that and allow that to regrow and proliferate. So just quickly on some of the gastrointestinal symptoms that some of my clients are experiencing. So you've got, because of this gut-brain interaction and the nervous system inputs, the way that our digestive system works, it prefers to be working, and it's more active when we're in a relaxed state. And of course, in a long COVID presentation, a lot of people tell me that their nervous system is permanently activated, and that's going to have negative consequences on their overall gastrointestinal function. So the vagus nerve, which is the nerve that comes from the brain and connects right into all of our digestive organs, is that those signals are potentially compromised. So what that's going to end up with is compromised digestion. So that's going to result in poor stomach acid production, maybe poor saliva secretion, poor digestive enzyme secretion, sluggish bile flow. It may end up with conditions such as gastroparesis, which is where the digestion really does slow down, and it can cause a lot of gas, bloating, abdominal distension, lots of burping, and it can also contribute to a kind of condition that is known as SIBO or SIMO. SIBO is small intestinal bacterial overgrowth, and SIMO, which I prefer to use, is small intestinal microbial overgrowth, because it may not just be the bacteria that are causing a problem. And what SIBO or SIMO is just the colonization of certain species in the small intestine when they shouldn't either be there or they shouldn't be there in large quantities. And again, this can contribute to things like constipation, diarrhea, upper gastrointestinal bloating, and a lot of the symptoms that people experience. Now, the temptation is to go on quite heavy elimination diets as a result of this. And the problem with going on, say, a FODMAP diet or putting in any antibiotic therapy or antimicrobial therapy is that, yes, you may reduce the kind of potentially pathogenic species, but you're also going to affect the beneficial species. And if someone's already low in Akkermansia and Bifido and Lactobacillus, I think putting an antibiotic in is really detrimental, because you're going to contribute to further takedown of that species and potentially even wipe it out completely. So we need to take a different approach to these SIBO type presentations and think about how we can introduce certain fibers into the diet that aren't going to contribute to this gas and bloating, but help to grow the beneficial species around it. Because if you can grow these beneficial species, then you have more chance of making sure those kind of not so friendly species are going to be dealt with. body has very good mechanisms to kind of cope with all of this. We just need to manipulate it in the right way, as opposed to go all out kill. So with regards to testing, so SIBO testing and gut testing are two different things. So SIBO testing is generally breath testing, and you will take a challenge and then you will take a breath test. So the challenge is usually glucose, lactulose, and fructose. The problem with this SIBO testing is that the labs will only offer one type of testing. So that comes in at around 160 quid. And actually, you may not get a full picture if you just do a lactulose test or a fructose test or a glucose test. It is much better to do all three, but then it becomes really expensive. So some people have kind of looked into this in great detail, and it turns out that the lactulose and the fructose breath testing can give around 95% accuracy. So either one of those are going to be quite good. If you can do both, that would be better. The problem with SIBO testing is that it's only testing for bacterial fermentation. So if you get a negative SIBO test, but you're still getting those upper gastrointestinal symptoms, it may well be that there is a fungal element to that particular fermentation. So it doesn't necessarily rule out a small intestinal problem. So that's just something to bear in mind. And then we have the stool testing. So I work with a number of different laboratories, and I like all of them. So I don't necessarily affiliate with a single one. And again, I'm not, if someone's happens to have done a stool test from another company, I'm perfectly capable of interpreting those as well. So I do get a lot of people come to me who have had a stool test at various different companies, and then they can come to me for that interpretation. But I generally like Biome site because they're more cost effective, and they're actually collecting data on long COVID patients as well, which is really good. And the kind of negatives of it, I would say, would be that it's a consumer test. So the problem with that is that if you don't have a consultation or you don't have a proper review of your results, it can be quite confusing, and then you can start to implement incorrect interventions and make the situation worse. And it doesn't really provide details on yeast, parasites, digestive processes, and inflammation markers, but it is a really good microbiome test. And I've used it a lot. I'm actually a referring practitioner as well, so people can work with me once they've had their results come through. Then Genova Diagnostics, who I love, so they've got a comprehensive stool analysis. They're using a range of techniques such as RNA sequencing, real-time PCR. They also culture the stool as well to look for any bacterial and microbial cultures. And then what they do is they match up the antimicrobial or the antibiotic to that specific species, so that you know if you are going to go in with an antimicrobial, you're going to choose the most effective one, so you don't have to use it long term and affect the rest of the microbiome. And you can also add on zonulin, which is a tight junction protein which can assess the potential for leaky gut. So it's a really good test, but really expensive. It's over £300, but actually it gives you a really good overview of overall gastrointestinal function and also the gut microbiome, but also any other metabolites or microbes that could be contributing to a problem in there. And then your gut map, again, they use RNA sequencing, but they've got an AI database that they use where they've collected all of their research on gut microbiome, and they use this so they analyze the stool, but then they match up the stool results to personalized nutrition interventions. And again, they're at the higher price point, similar to Genova, a little bit cheaper. The other thing you can do is home tests. So you can do a gut transit stool test. So this is really easy because you can take in some food. So you need to take in a food that isn't going to be broken down by digestion. So that's sweet corn, it's kidney beans, or you can use beetroot as well. So beetroot will make the stool go red, which can be quite alarming for some people, but it is just the red of the beetroot. So what you would do is you would eat it on one day and make sure you don't continuously keep eating it subsequent days. So you would eat it for one meal on one day, and then you would record the number of days that you see that food come through your stool, and that gives you an idea of your transit time. And then you can do a 7-day stool diary as well. Now, if you are squeamish, then look away now, because I'm going to put up a slide with the Bristol stool chart. So this Bristol stool chart just gives you an idea of the composition of the stool that you're looking for. So the 1 and 2 range, you're looking at a more constipated bowel movement, and then 5, 6, and 7, obviously that's more looser, going into chronic diarrhea. And so really the kind of classical well-formed stool is within 3 to 4. That's really what we're looking for a healthy bowel movement. So you can do a 7-day stool diary to see what the composition of your stool generally looks like, because it can give you some really good indications. Now, some people don't actually pass a bowel movement for 7 days. That's really quite alarming, because that matter that is left within the gastrointestinal tract will be giving off toxic metabolites that could potentially be absorbed through the colon, and that can cause issues in itself. So it's really important that if you're constipated, you work with someone to kind of get your bowels moving. And even if that means you taking some form of laxative like Laxido, which tends to be non-habit forming, that can be better than leaving that stool in the bowel. So again, if you do have chronic constipation, it's really best to work with someone who is well versed in managing these types of presentations. And then I wanted to touch on medication. So again, I'll do another presentation with regards to this, because it's actually quite a big area of research, and it's something that microbiome specialists are really interested in. And when you kind of see people who are managing the symptoms of long COVID, you will find that they are on a lot of medications potentially. And I'm not saying those medications are bad, but we need to, particularly as natural health practitioners, we need to understand that there is an interaction between the microbiota and medication, and this term has been coined, which is called pharmacomicrobiomics. And this is where researchers are starting to look at the effects of medication on the microbiome and how microbiome structure affects medication, because the microbiome can either enhance the properties of that medication, so it can make it work better, or it can affect the ability of that medication to work. So even before that medicine has been detoxified by the liver, it actually goes through a process in the gut microbiome. Now, we really don't understand a lot about this at the moment, but I think it's a really interesting concept, because if you do end up working with people who are on quite a lot of medications, and you start to manipulate the gut microbiome and start to bring up beneficial species, then you have to bear in mind that there may be an effect on that person's medication. So they're going to have to work very closely with their physician or their GP to make sure that they are not enhancing that medication or lowering that medication. So it's really important for us to be aware of it. And I will share a copy of all of these studies that I have been talking about in the comment section or in their kind of bio on YouTube. So I just wanted to bring that up, that this is an area of research that's very much booming in the microbiome space. So what can we do about all of this? So as I said, probiotics are likely not going to change the structure of a gut microbiome. So you are going to see a lot of conflated claims out there from probiotic companies that are saying, they've got the next generation of microbial species, they've got this species, they're doing this, they've got this kind of level. But there has been research done on VSL, for instance, which is a really high dose. I think it's like 950 billion kind of bacterial species in that one product. So it's a very, very large dose of probiotics. And even that, you will see it coming out on a stool test because it's transient. So you'll take the product, you could take a stool test and go, oh my goodness, I've got bifidobacteria, I've got loads of lactobacilli, but actually it's probably just because it's coming through the gastrointestinal tract anyway. But if you test kind of a month later or 6 weeks later or 2 months later, you'll find that those probiotics haven't actually colonized. They've done those studies in VSL. So the use of probiotics should be very strategic. So there are certain strains of bacterial or probiotics that can do a specific thing within the gut microbiome. But again, it's transient and the effects are only there while you're taking it. I don't know of any probiotic that has actually been known to colonize the gut and then help the gut microbiome build back. So I would say, unless you're working with someone who's really looking at your gut microbiome and looking at your symptoms, I would not buy probiotics off the shelf to take. That being said, some people are having some good effects. So if you are taking a probiotic and it is helping, then by all means go for it. But really what you want to be doing is building up the gut microbiome. You want to be feeding the seeds. You want to be using prebiotics. So those are going to be things like galacto-oligosaccharides, human milk oligosaccharides, lactulose. All of those types of fibers can start to be introduced, and they've all been shown in the clinical research to improve bifidobacteria, akkermansia, and the lactobacillus species. They all do those to varying degrees. And things like apple peel powder and red polyphenol powder, or the fruits, so apples and lots of polyphenol-rich foods, can really start to bring back some of these keystone species if you have some of that within the gut microbiome. Now, if there is zero, if you're consistently on stool tests getting zero bifidobacteria or zero akkermansia, I actually don't know if they would ever grow back again. I really don't have that answer. And I think that's when fecal microbiome transplant or potentially gene editing of the gut microbiome may need to become more appropriate and more mainstream. But it is a case of watching this space. So I'm going to share much more of this information. I'm going to break all of these components down and do them in separate videos. So it would be really helpful for my channel. I've only just started it out. So if you could follow, like, share, get this information out. And I think there is a really big missing piece in the research into long COVID on the gut microbiome, and I'm just going to be sharing the things that I'm seeing in clinical practice and what I'm seeing with other researchers out there as well. So thank you for supporting me, and I am going to be sharing a lot more content on this in the future.